Practice set 3. For each problem, determine the measures of the missing angles. In problem number 5, we're given that line R is parallel to line S. When we're given a diagram with a lot of detail in it, a good technique is to cover up as much of that detail as we can to try and solve the problem. So if I eliminate most of this and boil it down to just the given angle and the angle adjacent to it, these two angles combine to give us a straight angle, which is 180 degrees, telling us that 50 degrees angle and the angle 1 are supplemental angles. So to find the measure of angle 1, we'll take 180 degrees, subtract the given angle to give us a resulting 30-degree measurement. Once we have that, and we bring our view out a little bit further, look at some more detail in this diagram, we have two lines that are intersecting. Intersecting lines form equal vertical angles, and vertical angles are angles that are across from one another. So our given angle 50 and angle 2 have the same measurement, giving us another measurement to this problem. Likewise, angle 1, which we just found the measure of, is across from angle 3. That means 3 also would have a measure of 130 degrees. Now we need to pull our focus out for the entire diagram and use the fact given in this problem that line R and line S are parallel to one another. When we have two parallel lines crossed by a third line, and here's our third line called a transversal, there's 8 angles that are formed. When we have angles that are in the same relative position, mathematicians call these corresponding angles. So if I look at the given angle 50, it's to the left of the transversal and it's above the parallel line. That description would also describe angle 7. It's to the left of the transversal, that third line that's intersecting the parallel lines, and it's above the parallel line. When you have corresponding angles, they are equal. I can use that same relationship to find the measure of the remaining angles that are unknown. For example, angle 3 has its corresponding angle with 6. Both angles are to the left. Both angles are below the parallel line, so it's equal to 130 degrees. Or I could have found angle 6 measurement by looking at its relationship with 7. 6 and 7 are adjacent to one another. They're adding up to equal 180 degrees. That means they're supplemental. If angle 7 is 50 degrees, 180 minus 50 is going to give us the 130. We can find the measure of angle 5 because we have vertical angles here. 5 would have the same measure as 7 because they're opposite from one another, or using the corresponding angle relationship, the angle that corresponds with angle 5 would be angle 2. Both of these angles are to the right this time of that third line called the transversal, and they're both below the parallel line. That means angle 5 is 50 degrees. The last angle, 4, corresponds with 1. They're in the same position. They're both to the right of the transversal. They're both above each of the parallel lines. They're corresponding. Corresponding angles are equal. Or other options would be 4 is a vertical angle to 6, meaning it would have the same measurement. Or we could look at 4 and 5 are supplemental angles, adding up to 180. If we have a 50 degree, that means angle 4 would have to be 130 degrees. In problem number 7, we have a circle, and they're asking us to determine the measure of angle X. There are 360 degrees in a circle. Knowing this fact allows one to determine the size of the angles drawn in the circle. As long as the angles have their vertex, the vertex is the point where the sides intersect, is at the center of the circle, we can use the fact that a circle contains 360 degrees. So the entire rotation would be 360 degrees. They're indicating part of that rotation is 250. What's the remainder? To answer that, we'll take 360 degrees, the entire number of degrees in a circle, subtract what is given to give us the resulting angle that's missing. And when we subtract those, we end up with 110 degrees.